Okay, this is going to be a video on a couple things. It's going to be on exponential applications and then regression. First thing we want to talk about is compounding money. There's two formulas. Now this is an exponent. You use this for regular compounding. You use this for continuous compounding. What P stands for is the amount of money you're starting with. R is the rate. You have to convert that to a decimal. N is the number of compounds in a year, which, skipping forward, so monthly, that would compound 12 times. Quarterly would compound 4. Sorry, let me change this real quick. Quarterly is 4. Okay. Semi-annually is 2. Yearly would be 1. Daily would be 365. Okay. T stands for years. E is the exponential function, obviously. And A is the amount of money in your account after compounding. Okay. All right. So it says Sasha has $1,000 to invest from her grandma. She gets a 5% rate on her investment, plans on investing for 7 years. How much money is compounded monthly? So the way that would set up, I'd have 1,000. 1 plus the rate, 5%. I think we should all know that. To get the rate, you just divide by 100. So that's 0.05 as a decimal. Okay. The number of compounds would be 12. And then the exponent would be 12 times 7. Okay. So when I type that in, what I do is 1,000. Okay, 1 plus 0.05 divided by 12, close the, whoops, let me put the parentheses around the division, and then the parentheses in there. Then I got to make an exponent, and then that's 12 times 7. Make sure you put your exponent, okay? So that's going to be $1,408. $18. Okay, 0.03. Okay, now what changes if it's quarterly? The only thing that changes is we're going to divide by 4. And it's going to be 4 times 7. Okay, all right, 1,000. 1 plus 0.05 divided by 4. There, whoops, hold on. 0.05 divided by 4. All right, exponent 4 times 7. Okay, 14, 15, and 99 cents. Okay, semi-annually would be 2. The exponent would be 2 times 7. Oh, whoops, didn't type that right. 1,000, 1 plus 0.05 divided by, keep doing that, keep not hitting that parenthesis, divide by 2, close it again. Exponent, 2 times 7. Okay, 1412, 97 cents. Okay, all right. How much is it compounded continuously? So what I'm going to do is I'm going to do 1,000 E to the 0.05 times 7. 1,000. Shift E, exponent 0.05 times 7. All right, 14.19 and 6 cents. Okay, how many years is it until she doubles her investment? Okay, all right. So in this, let's say we're assuming continuously. Okay, so we don't know how many years. So I'm going to go ahead and use X. Okay, so what I do, okay, is I'm going to go to graph, type 1,000. Okay. e to the 0.05x. Okay, draw. Now you're not going to see it. We're going to go zoom auto, and then we're going to zoom out, execute. We're going to zoom out a bunch. Okay. Now, what does it mean to double? That means that the y would be twice as much as the initial. So the y is 2,000. Okay, so I want to do gsolve, scroll over, ycal. I'm sorry. Gsolve, scroll over. I want to calculate when that's going to happen. So I'm going to put x and I'm going to put 2,000. Okay, and that would be 13.86 years. Okay, all right. So if I'm trying to figure out how many years, that's the x. So I'm going to do the xcal. All right, where the doubling is that. Okay. All right. And what we can assume here is continuous compounding. All right. You can go ahead and work on this one on your own. All right, growth and decay. It looks like a very similar formula to basically the exponential growth. The big thing is, okay, this is NO is the number you're starting with, is E is exponential, K is the growth and decay rate, T is years. Now, if your growth rate is positive, okay, you'll have your growth rate, you'll have a positive K. If you have a decay rate, you'll have a negative K. So as this moss continuously grows at a rate of 2.5%, if the amount of moss is 4 square meters, how much moss is there by year 5? Okay, so I would start with 4, okay, E, okay, if my rate is 2.5%, 2.5 divided by 100, that's going to be 0.025, and since it's growth, it's positive, okay, times 5 years, okay, so I just go ahead and calculate that, okay, parentheses 0.05. 0.25, sorry, times 5 years. Okay, so that's going to be 4.53. Okay, what's the moss growing? Wood on a house trim continuously decays at a rate of negative 4.3%. If the amount of the house trim is 10 feet, how much is left after 4 years? Okay, so I got 10 E. Okay, all right. 4.3 divided by 100 is, I would have negative 0.043, okay, times 4, all right, 10, E, exponent, negative 0.043 times 4, okay, that's 8.419. That would mean that the amount of wood is rotting or decaying, okay? So all you got to do, the difference is basically the growth versus the decay rate, okay? Am I having you practice yet? Okay, go ahead and give those a calculation try, okay? All right, now let's talk about something called half-life. Let me change that at the end. Okay, half-life, all right? What half-life means is obviously there's half the amount that there used to be, okay? All right, it says the half-life of a mineral rock is 50 years. What is the rate of decay, okay? So, the idea is that if you use this formula, okay, all right, that's 1 E to the R times 50, okay, all right, that's your rate, okay, so basically there's a couple ways to do this, all right, if you divide by 1, that's 1/2 equals E to the 50 R, okay, all right? If you take, you convert that to a natural log, okay, all right, because that's how you would solve the natural log problems, okay? That would be natural log of 1/2 equals 50R, okay? So the natural log of 1/2 is that divided by 50. So my rate is, R is negative 0.013, okay? All right, and that's how you get your answer. All right, the other thing that you could do, I think you'll end up with the same thing, is you could always graph this. So you could graph e to the 50x, okay? You draw it, you zoom auto, and this is going to be probably hard to see. This is not the best way to do it. So you go G-solve, you want to do an X calculate, and you want to put in 0.5. And that's another way to get the same problem, okay? So it all depends upon what you want to do. Okay, so the half-life of a dogwood tree is 15 years. What is the rate of decay? So once again, that's 1/2 equals 1 to the E 15R. Once again, you can solve this a couple ways. You can do natural log of 1/2, move the 15R over, and I go natural log of 1/2 divided by 15. My rate is negative 0.046, or about 4.6% if you think you multiply that. All right. The other thing you could do is you could graph it where it's e to the 15x. Okay. You draw it, zoom auto, zoom out. You can't really see it because the e thing gets so big so fast. Okay. And then we would do G-solve. We're doing an X cal. And we want to know what's it going to be 1 divided by 2, and it's the same thing. So there's two ways of basically getting to the same problem. Okay, all right. That was one you probably should have practiced on your own, but all right. You try that. Okay. All right. Now let's move into regression. Okay. Second part of these applications is regression, and what we want to choose between. We want to choose between x squared, x cubed, and exponential regression. Now, sometimes they may tell you, but if they don't, what you're looking to do is put in the table, okay? Put in this table, and you're going to find an r squared value. We want to pick the function that's the closest to the number 1, okay? All right? So what I do here, I go to menu and table. Sorry, I go to stat. I apologize, I go to stat. I put in my values. 1, 2, 3, 4, 5, 6. Okay. Then I put in the y's. 1.5, 4.5, 13.5, 40.5. 121.5, and then 364.5, okay? All right? Now, as a reminder, quadratic, cubic, exponential, or sometimes it goes this way, all right? So, what I want to do is I hit calc. So here's the process. We go to stat, we put in our values, we hit calc, okay? All right? We select regression. Okay, so that's what we're doing. Now, what you want to do is if I select x squared, that r squared value, okay, tells me if it's closer to 1 that's probably it. Well, that's 0.95. Let's hit exit. Let's go to cube. That's 0.996. Pretty good. Okay, now I scroll over. I'm going to select exponential. And as you can see, okay, as you can see, that r squared value happens to be 1. So this is an exponential. Now, my calculator, you can write either one, but basically what this is you got y equals, you get a choice of a, b, x. I do not get that choice, okay? So that is 0.5 e to the 1.09 x, okay? That would be the equation, all right? If you're doing the ABX one, let me just do it real quick in my calculator here. .5, 40.5, 121.5, 364.5, calc, reg, scroll, exponential, ABX, okay? If you're doing the ABX one, okay, this is the values you get, okay? So if you're doing the ABX one, that's gonna be y equals 0.5, 3 to the x power. Okay, so that's, either way, you're going to get the same answer. Okay, now what you want to do is you want to hit copy. Copy, and then I want to hit execute. Okay, and what that does is it moves it over to the graph area. So I can go into menu and graph. Okay, I have to hit select, which is F1. Okay. And then I'm going to hit draw. Now, I have to play around with the zoom feature. Zoom auto. Okay? Then zoom out, execute. Actually, let me do this. Let me hit F3 twice. Let me draw it. Zoom auto. Okay? Zoom out, execute. Zoom out, execute. Zoom out, execute. We got the exponential. Now, what I want to do is go to G-solve. We were sort of doing this earlier. G-solve, scroll over. It says find y when x is 12. So I want to do a y cal and put 12 in there. That's 265,720.5. Okay? Find x when y is 300. Okay? So I'm going to find x when y is 300. And it's 5.822. Okay? And so that's the process that you want to go through. Okay? All right? So let's go to the next one. All right? Years and the cost of car insurance. Now, what you want to do is keep in mind that's going to be your X, that's going to be your Y. All right? So I'm going to go to menu and stat. Okay? I'm going to delete all these. Okay? I want to do 1, 2, 3, 4, 5, 6, 7, 8. Okay? 12.124.9, 103.6, 88.1, 78.4, 74.5, 76.4, 84.1, and 97.6. Okay? So calc, reg, let's check them all. X squared. That one, it nails it right on there. Is R is that. So what I do is my equation is y equals 2.9 x squared. Okay, so that A is there. The B is negative 30. And the C is the standalone number of 152. Okay, copy, execute. Okay, then I want to go into the graph area. All right, hit select. I'm going to draw.
Hello, at this time, any and all students who are not
Zoom auto, then zoom out, execute, zoom out, execute, zoom out, execute. Now, it says, what will the car insurance be by year 10? Well, what is 10? 10 is X for year. So we're going to calculate the Y. So G-solve Y cal, and we're going to put in 10. Okay? And that's going to be $142. Okay, when will that reach 150? So the 150 is the y. So we do G solve, we're gonna do an X cal and put in 150. Okay, now, you gotta check with the quadratics the multiple years. Because right there, 0.06 years doesn't make sense. If I hit over year 10.2 or year 10, all right, would work. And you can just say 10. Remember, all of these are estimates, okay? So always check for multiple answers, all right? And this is like a real estate thing, like years, homes sold. Now, when you have these years, what you should do is make this 0. So the difference between 2010 and 2018 would be 8. The difference between this one would be 11. And the difference between this one would be 20. So if you put those in, that's probably going to be a much better result for you. Okay, so let me go to menu and stat. Okay, I'm going to delete these. Okay, so I put 0, I put 8, I put 11, and I put 20. Okay, and this is 47, this is 74, this is 120, this is 247. Okay, all right, calc, reg, x, all right, that's not bad, 0.993, that's pretty good. X cubed, boom, that gives me 1, so that's what I'm going to use. Okay, so if I scroll down, I can see, all right, I got negative 0.05, x cubed, 2.21, x squared, negative 10.5, x, and then plus 47. That would be the equation, okay? How many homes, all right, let's do this, let's go copy, execute, menu and graph, okay? Select, draw, I'm gonna hit F3 twice, okay? All right, and now I want to zoom auto, then zoom out, execute, zoom out, execute, zoom out, execute, okay? All right, so how many homes will be sold by 2040? Well, 2042 would be right here. That'd be a difference of 32. So I'm going to do a Y calculation there. Put in 32. Okay. All right. So this person dipped at 31. Okay. All right. Make sure my thing is right. Okay. All right. And then when will they reach home sales of 500? So I'm going to do an X calculate and put in 500. And I don't know if that's going to work. I'll do X calculate 500. I don't think that's going to work. Yeah, that's not gonna. That actually did not end up with the negative answer. So the answer would be none in this case. Okay. All right. It's sort of a probably question on how that ended up. Okay. So I have a worksheet for you to do for regression. Okay. All right. The big thing with regression: see if that R squared is closest to 1.